Hello, good morning, students. Today our topic is hot climate stress physiology. Hot climate basically is when the temperature is above the normal temperature. So, the hot climate of desert basically is testing environment for the living creature. The hot days and cold night means they need to be well equipped to deal with the extremes. These factors, along with the hot climate, lack of water, and shelter, has resulted in animals adapting their body to suit the climate. So, according to the Bergman rule, the body mass it is variable depending upon the temperature. If the temperature is low, high body mass is present, and if the temperature is high, low body mass is seen. So animals in hot climates have adapted behavioral pattern to avoid the hottest part of the day. For example, Costa's hummingbirds breed in late spring and leaves the area for the hot summer. Even the reptiles and mammals are only active at dawn and dusk. Burrowing is the another useful mechanism seen in the case of many reptiles. Lizards bury themselves in the sand during the day, while the rodents they create burrows and plug the entrance to keep out the hot air. Toads, frogs, and desert tortoises escape the heat for months at the time by estivating in burrow. Estivation is the summer sleep. During estivation, animals are dormant with reduced breathing and heart rate, allowing them to escape high heat and conserve water. Most desert biome animals limit their above ground activity in summer to twilight or evening hours. Some desert animals, such as antelopes, squirrels, and camel, are active during hot summer days because they can allow their body to accumulate heat without harm. They show hyperthermia. Body temperature rise to 40 degrees Celsius or more, doing away with the need to cool themselves by evaporating body water. Squirrels lose excess heat to shady surface and camels to cooler night air. Desert sheep, goat, camels, and donkey retain insulating fur on the top of their body, but they have sparsely covered abdomen and legs that radiate excess heat. Jackrabbits have long legs that carry them well above the heated ground, and ears are very large, well equipped with the blood vessels. The blood flow to the ears increases to lose heat to the cooler air, and flow decreases when the air is hotter than body temperature to avoid overheating. To save water, normally the desert animals they produces dry fecal matter and very concentrated urine. Specialized desert dwellers such as kangaroo rat have faces 5 times drier than the laboratory rat and urine twice as concentrated than the white laboratory rat. Lizards, snakes, insects, and birds excrete uric acid rather than the liquid urine. Small rodents and birds such as cactus wrens have specialized nasal passages that cool the breath before it is exhaled, condensing water for reabsorption. Many desert lizards possesses nasal salt glands that excrete potassium and sodium chloride with very little water loss. In hot climate, the problem is not the maintaining body heat, but in dissipating it. Normally, the body gets rid itself of excess heat by sweating. In condition of humid heat, however, the humidity of the surrounding air prevents the evaporation of perspiration to some extent and overheating may result. Hence, the heat adapted person in humid climate is characteristically thin and tall, follows the Allen's rule, so that maximum surface area for heat radiation is there. He has little body fat, often wide nose, since warming of air in the nasal passage is not desirable. Usually dark skin, which shields him from harmful solar radiation and may serve to lower his sweating threshold. Then camels have a thin layer of fur underneath their bellies to help lose heat, while thicker layer across the hump which shades them. Owls, nighthawks fly around with their mouth open, so water is evaporated from the mouth. So vultures, they show another important phenomena known as urohydrosis. They urinate on their legs so to cool them down as it evaporates. Vultures can also fly high in the sky to experience cooler air flow. A camel has adapted to heat by being able to go for long time without drinking water at all. Mammals have adapted to extract water from the cacti. Small insects obtain nectar from stem of plant while larger derive water from leaves. Kangaroo rat burrows into hole and recycle the moisture from their own breath to get retain water. Some rodents have additional tubules in their kidney to remove extra water from the urine so that it can be returned to the bloodstream for hydration. As the rat exhales, water condenses on its nasal membrane. This process means the rat can conserve a lot of water, so it does not need to drink for day. Kangaroo rat can radiate heat to bring temperature down. Even the kangaroo rat have sweat glands only in their feet. Reptiles and birds have adapted by excreting uric acid as a white compound that lacks moisture. This means they can retain vital water for their body function. And other animals like camel also have a large surface area to volume ratio to get rid of heat effectively. So these are the different tubules present in the kidney in beaver, humans, and kangaroo rat. In kangaroo rat, the loop of Henle is very long for conservation of water. These are the Maasai people living near the equator in Africa. They follow the Allen's rule. They are thin, they are tall, their extremities they are very long in order to radiate the heat. Selective use of clothing and technological inventions such as air conditioning also allows humans to thrive in hot climate. One important example is in the case of Arab people who live in Sahara Desert. They wear clothing that traps air in between skin and the clothes, preventing the high ambient temperature from reaching the skin. In the case of Rajasthan, they wear turban in such a way to enclose a sheet of air between the rounds as to protect their head from the high temperature. Thanks www.google.com for providing us beautiful pics so that we can explain our topic well.